Hey guys, Mr. B here again, bringing another math video. This one I actually did in class today with my students, and it is solving exponential equations using logs. So I'm going to do a couple of examples, and my students are finding this difficult because they find finding the exact solution a little bit complex. So I'm just going to start simple with a couple of different examples, and then we'll sort of build our way through. So let's say we had an example, maybe something like this. 7 to the x is equal to 12. So that's an exponential equation, a fairly simple one, where we have an unknown exponent here, x. So this is what we're trying to find. We're trying to find x. And normally we might look at it and say, well, can we find a common base between 12 and 7? Of course we can't. 7 doesn't break down at all, and 12 doesn't break down at all. So we need some other means. That other means is logs. So what I like to do is I like to take a log of both sides. So that generally works for me 99% of the time. Some people like to change the logarithmic form. I don't like to do that. I like to just take the log of both sides right away. So we go log of 7x and then log of 12. And I like to use the rule that if I have an exponent inside my log function, that I can take it down and put it in front of my log function and multiply it. So for example, if I had log of 4 squared, that's exactly the same as 2 times log of 4. So that exponent can come down and plop right in front. So we can do the same thing if the exponent is x. So this becomes x log of 7 log 12 is equal to log 12. And then what we do, in order to get x by itself, we divide both sides by log of 7. Just like that, so we end up with x is equal to log of 12 divided by log of 7. So that is the exact solution. Anytime you have you're looking for an exact solution and you don't have common bases, then you're going to have a log in your answer. Simple as that. Alright, let's try another one. Let's make this one a little more complicated. So let's say I have something like 3 to the 2x plus 1 is equal to 8. So the difference in this one is that I have a slightly more complex exponent. So what I should do with this one is exactly the same thing. So I take the log of both sides. So I go log 3 2x plus 1 is equal to log of 8. And then I can take my exponent, just a little bit more complex, 2x plus 1. And I'll put that in brackets, and I'm left with log of 3, so my base stays. That's equal to log of 8. So now I have a couple of options. So I can divide both sides by log of 3 here if I want to. I can also distribute through with my log here. And that's not a bad option, but it doesn't really matter. I like to divide by log of 3, but my students really like to distribute in with this log. So that's what I'm going to do. So this becomes 2x log of 3 plus log of 3 is equal to log 8. So now all I do is I'm going to subtract log of 3 from both sides. So you can see how there can be a little bit of a difficulty spike in this pretty quick, right? Just by adding a slightly different exponent, you have a lot more algebra going on. So these logs cancel. So now I'm left with 2x log of 3 is equal to log of 8 minus log of 3. And now I need to get x by itself, so I can divide this guy by 2 log of 3. And then I have 2 log of 3. So I end up with x is equal, so that's my x that gets left, is equal to log of 8 minus log of 3, all divided by 2 log of 3. Just like that. So there it is. There's my exact solution. So you can see that's pretty tough. That's not an easy thing to do. And of course, it gets even more complicated than that. There's always an of course, right? You always have to wait for the other shoe to drop in math. So let's try this one. So 3x plus 1 is equal to 5 x plus 3. So this time I have exponents on both sides. So again, I have to take the log of both sides. So I get log 3x plus 1 is equal to log 5x plus 3, just like that. So those exponents come down in front. So I have x plus 1 log of 3 is equal to x plus 3 log of 5, just like that. So again, you have options. You can divide both sides by one of the logs, but my students prefer this, to double distribute. And I actually think this is probably the easier way. Kind of makes a little bit more sense. So I end up with x log of 3 plus log of 3. And that's equal to x log of 5 plus 3 log of 5, just like that. And so now all I want to do is get my x's together. So I need to take this over, take that over. So when you take them across, they change sign. So I get x log of 3 minus x log of 5. So I took this over to the other side, just like, you know, if I subtracted off x log of 5 from both sides. And that's equal to 3 log of 5 minus log of 3. Excuse me. So now I'm almost done. So I need to factor out an x out of this side. So I factor out an x, and what I get left with is log of 3 minus log of 5 is equal to 3 log of 5 minus log of 3. Divide both sides by log 3 minus log 5. And we are essentially done. Just got to rewrite this side here. So I know what x is equal to 3 log of 5 minus log of 3. I'll divide it by log 3 minus log of 5. And there it is, guys. So I hope this helps you on your journey to figure out how to have exact solutions of exponential equations using logs. They don't get a whole lot more difficult than this, but I'm going to make another video with a couple of examples that's a little bit harder. So if you're looking for something harder, stay tuned and check out my next video. And thank you guys for watching. Like, share, subscribe. Help me share my math help with other people. I love that. I love helping other people with math. Thank you very much. See you guys in class.